Hey, here we are already on part 4.1. In this video we're gonna talk about the crystal strands. Without further ado, let's dive in. So this is where we left, and one thing we noticed is that some of the crystal doesn't exactly match the size of their proxy, which can be annoying sometimes, so we're gonna fix that very quickly. So I'm arranging a bit the graph and dropping a match size that I'm plugging after the cluster. And for the next part, we're gonna drop a tube right after it. And this tube's gonna be basically the same height than our crystal, so that's pretty handy. And we're gonna increase the number of columns. Yeah, that should be enough. And we're gonna reproject this tube on the crystal. Let's change the method to minimum distance. So it looks like my display is wrong right now. Let's come back. And that would work. So that's gonna be a good base for the strands of the crystal. I'm gonna actually increase the columns a little bit. And let's copy paste the null, and we're gonna rename that crystal A lines. And let's copy this setup, and we're gonna paste it into all the other graph. So we passed that into the other crystals, and don't forget to add the match size to the proper place, scale to fit, and rename the output properly. So I don't think I told it so far, but you can create a dot on your graph by pressing Alt click, and that should create a derivation dot. So okay, almost there. All right, that seems to fit the crystals pretty well. Okay, so we're gonna start working on the strands. So I'm gonna copy this context and actually rename the original intersection solver. So sorry if it was confusing. I prefer like keep everything in their own room so that everything is clear. In this object merge, I'm basically grabbing the new output we created, the output line, so that we got the new geo with all the lines that we're gonna use as a strand. And if we check out how it's looking, we have crystal with a lot more lines now. We're gonna need to isolate them though. So one thing I like to do, just to be sure, is to unshared edges. And I'm gonna call that sides. And I'm just gonna drop a group combine. And let's grab the sides, and we're gonna set it to equal all but. So that's inverting the selection. So there are many ways we could have select those, but I just wanted to show you guys how to invert selection. Now we can drop a dissolve and dissolve everything but the sides, like so. So now we got some curves. That's pretty cool. They don't exactly have the shape of our crystals though. So let's go in the crystal scattering, drop a null. Let's call it output scattering or whatever you want. Gonna put a little color like black, and go back in the strands, and in here we're gonna object merge this scattering crystal. Where are you? Yeah, that guy. Sweet. So we could make a test. We're gonna first resample all those lines so that we got enough points to project. Right now it's very spaced out, so we're gonna reduce the length to increase the number of points. That's a lot of points, but you'll get the idea in a sec. Let's add a ray node to project, and now, oof, that's pretty interesting. I kinda like it, but it's not what we want. So let's just switch to minimum distance, and now we got the proper shape of a crystal. Just disable show guide geometry so that it's running a little faster. One thing though is that we want to randomize the length of those guys. So let's drop a carve. All right, So the first thing is that if we start playing with first view and second view, is just not what we expect, or what we should expect. So let's drop a convert line, and now that's actually what we want, is something that trims the line along its length. So that's pretty cool. The plan here is gonna be to set 2 different lengths for those guys and blend that together with the edge breakup we created into the rock base. So let's go back in the rock base and grab this guy, copy paste it into the strength context. So now we're gonna plug in one input in here and the second input in a longer one, like so. All right, so that's a very cheap way to actually randomize the length. We could have like iterate through a for each primitive and apply random values to the carve node, but I figured that this solution is actually much faster, and well, it's pretty flexible. You can achieve the result you want by driving the noise, so let's just do that. We can also like copy this guy, the edge breakup, and do a breakup into the breakup, like Inception. So you can probably try some smaller or larger frequency, like let you experiment whatever fits your need. In that case, that might be too short, but why not? Yeah, I kind of like how it's randomizing the length of those guys. Okay, let's keep going. We're gonna now sort this primitive and delete randomly some of them. So with the sort node, I'm randomizing the primitives. Oh, my bad, I think I just randomized the points and not the primitive. So now if we change the seed, you see the prim number changing. So that's pretty cool. We could use a delete node and set it to primitive. Well, the primitive is default anyway. So let's delete by expression and type in @primnum, which is the prim number, smaller than, let's say, 50. And if we do delete non-selected, it actually picked the 50 lines that were under this value. So we're gonna type @numprim divided by, let's say, 2. numprim, like so, which corresponds to the total amount of primitive. And actually we're gonna make a controller so that it makes things a little easier. I'm gonna call that amount and copy that guy, paste it as relative reference in here. And now we can pretty much thin out the result of those lines. So that's pretty cool. I say cool a lot, but yeah, why not? That's pretty sweet. Okay, let's keep going. Let's see if we try to reproject. So we got some weird like stretching going on. We're gonna fix that. So let's drop a group and we're gonna do a selection by length. So let's set it first to edges and we're gonna call it long edges, very original name. And let's set minimum edge length. So it will depend on the resample value, but everything that is greater than that will be selected. So in that case, seems to do the trick. And let's dissolve this long edges group and uncheck removing inline points. So that's pretty sweet. Some of the projected points looks a bit funky. We could probably try to smooth them. Really depends how noisy is your crystal and stuff. Maybe you don't need any smooth. It's up to you. Right, now it's time. We're gonna try to mesh this guy with a poly wire. By default it's probably too high, so let's drop the wire radius. Will depend on the scale of your scene, of course. Okay, so I'm thinking if we check out with the crystal, okay, I'm gonna apply a color actually so that it can stand out a bit more. Sweet. Alright, that's not bad. There's definitely some weird things, some things we could improve. I'm kind of thinking we could try to increase the base number of columns into the different crystal, for example. And actually, I'm not sure the smooth would be so useful. We could instead reduce the scale in the ray node. In that case, 0.5 might be a good in between. Right, so that's pretty sweet. We see them a little better now, I think. This is bugging me though. There are some floating strands because, well, the intersection doesn't match. So we're gonna go in the crystal scattering and copy this section that we created for our crystal, high-res crystal, and pass that into this graph. So we're gonna get rid of the for each loop so that everyone's using the same kind of intersection, and probably will make things a little faster. So let's pass that and reconnect everything properly. Now, one thing we're gonna notice is that it's not gonna work straight away because the high-res crystal were packed, while on new proxies for the lines are not. So let's see. So this is packed, as you can see. We got just 1 point, while this input is not packed. So we could try to unpack this guy and transfer those points, the group of those points onto those points, and see what happens. It's not exactly successful. I would say should rather like keep everything packed. So let's copy paste the assemble node and unpack at the end. That would be a smarter solution. Yep. So that's before, after. That seems all right. Let's check out the final node, and let's see with the rest of the graph. So there are still some floating things. I think it's because the threshold isn't high enough. So like this part here is a bit floating again. So let's go in here and increase to 0.1, and that should do the trick hopefully. Yep, all good. That's perfect. Well, kinda perfect. Kinda perfect because we could still use some more columns in general. So I'm gonna crank that up to 100. And after that, we're gonna need to randomize the radius of those lines. Yeah, that's pretty sweet, but we could really use some variation in the radius. So let's do some basic vex. We're gonna create an attribute wrangle and run it over the primitives because we're gonna need some primitive attribute. So we're gonna create a radius attribute that's gonna be equal to a random value of the prim number, like so. If we check out the spreadsheet, we do have one random value per primitive between 0 and 1. You get the ID, and of course we're gonna need to refit this value. So let's type in @radius equal fit 01, which is basically a fit range into a point VOP, and we want to refit the radius attribute between, let's say, 1 and 3, and that's what we get. Some values between 1 and 3. In that case, we're gonna create a controller that we're gonna call min radius, and another controller for the max radius. Let's click the plus to create those controllers, and now we do have real-time control. We don't need to type in stuff. That's much better. So in here we could try and actually apply the radius attribute but it's only running on points. That's something to consider. So we need to promote the radius attribute we created into points. So make sure the original class is primitive and the new 2-point. Let's actually divide the result by 100 because my scene is it's not at this kind of scale. And yeah, now it should act a little better, so that's pretty cool. There's one thing we could use, thinking we could remap with a ramp the random values. To do that, let's just type chramp and put that in parentheses. And the name of the controller is going to be just control. And yep, now we got a curve. And if we decrease the middle points, it's going to drop the values of the radius to something closer toward 0.3 in that case. Let's expand the graph. We're gonna, I think, use B-spline. Yeah, that's much more interesting, I think. I'm thinking right now, I'm still not quite happy with the breakup, so I'm gonna tweak a bit the edge breakups, which is not really an edge breakup per se, but you get the idea. It's just a random breakup in that case. Yep, that's much better for me. Gonna clean the graph real quick. Let's put some colors, attribute radius, and that's gonna be a orange color for like utility node. A little backdrop for that guy. We're gonna call it trim lines. Very original. That's gonna be for the intersection, blast intersection. And those two guys is basically the point input scatter points. All right. And to finish, we're gonna add a null. I'm gonna call it output strands. And in the next video, we'll see how we can connect some additional strands from this crystal to the rock. And also use that as a guide to drive the fibers.